Welcome back friends. Today we are going to solve LintCode problem 875 longest line of consecutive one in matrix. So this problem is asked by Google. So make sure you understand the problem and practice this problem if you are trying for coding interviews. So let's go through the description quickly. So given a 0 1 matrix, find the longest line of consecutive 1 in the matrix. The line could be horizontal, vertical, diagonal or anti-diagonal. The number of elements in matrix is 10,000 maximum, and they have given us one sample example here. So here as you can see, line can be like this, right? This one and this one. Diagonally if you form a line, then its maximum length is 3, right? 1 2 3. So that is what we have to return, the length of the line, maximum line, right? We should return. So let's take this example, one example over here where we will discuss how we can solve this problem, right? So for example, this is the input matrix that is given to us and we have to find out longest line in this matrix, right? So let's just I'll just show you what longest line means. Here longest line can be vertical, right? For example, this one can be one line basically, right? This line is vertical line, its length is 3, for example, right? If you consider a horizontal line, for example, if you consider this horizontal line like 1 1 1, this one is a one horizontal line of ones, so this length is also 3, right? And so this is the way a line can be formed. That's what they are saying, either vertical, horizontal. Now I showed you vertical and horizontal, I'll show you now the diagonal. So diagonal line can go from this one, right, like this. So you can go make a line like a diagonal line, right? So this is one of the diagonal line as I am showing you, and this line is the longest line in this matrix, right? Its length is 1 2 3 4 5. So 5 is the length of this longest, this is the longest line in this matrix, and this is a diagonal line, right? From, so if you are at this one and you start doing a DFS in the diagonal way, like you can go from this one, you can go from this one, and you are diagonally going and doing a DFS, right? So you can do a DFS here, then diagonally from this one you will go here, then diagonally from this one you will go here, and diagonally from this one you will go here, right? So you are going as long as you are getting one diagonally, right? And you are applying DFS basically diagonally, right? And you got 5 as the length. So this is how we are going to formulate our solution. We will be using a DFS and we will be going in, so there are 8 directions you can go basically. So I'll show you that. So let's just revert this back so again I can show you. So now why 8 directions we can go? If you are standing at this ijth cell, right, you can go upward, or you can go downward, or you can go on the right side, or you can go on the left side, right? So right side and left side mean horizontal, and up and down means vertical you are going, right? If you are going in this direction, you are going diagonally, right? Or you can go in this direction, downward. So you are going in a diagonal direction. And this is also another directions which is anti-diagonal. Now you are going in this direction and you can go in this direction. So as I have mapped, so these are the 8 directions you can go to form a line, and you have to find out which is the longest line you can form basically, right? So as you can see, I have denoted the cell coordinate, right? For example, if you are looking at this up cell I minus 1 j, right, this is what it will be. If you go downward, it is I plus 1 j, right? Next row and j, same column basically. So similarly you can see all the 8 directions as I wrote it here. So our approach to solve this problem is we are going to do DFS. So we will start basically iterating this matrix from this 0, right, first cell basically, and we will go like line by line basically like this, right? So first line, first row, then second row, then third row, like this we will go. Okay, and then we will, whenever we find a 1, so for example this one we will find, right, whenever we find a 1 we will do DFS in one direction. So we will implement DFS functions. We will implement 8 different DFS functions, right, each for one direction. For example, if I am going horizontally, then I will just go like this horizontally all the way until I can go, right. Whenever I get a 0 I cannot go basically, so I'll return. Then this is the one DFS function we will implement. Other DFS function we will implement is if I am going diagonally, then I'll go this one, then I'll go this one, I'll go this one, I'll go this one, right. So this is one diagonally, so this is another function we will iterate. This is a DFS, right. So it will always it will travel diagonally as much as it can do, right, means until it finds 0 it will go. Similarly, if it will try to go in this direction also, right, downward, so this will also, it will go here, but once it reaches 0 it will just return, right, it cannot go after this once it finds 0. So the idea is to go in 8 directions, so we will have 8 different DFS functions, each for one for each direction, and in every DFS function we will keep track of the maximum length it can form, right. We will keep track of maximum for in each direction. So for example, if you start in this direction, for example here, right, this one, then the maximum will be 2, only 2 is the length at that time, right. Then when you are going in this direction diagonally, then 1 2 3 4 5, then 5 will be the maximum, so you will update this 2 to 5, right. So similarly you will check all other directions basically in the DFS, and then at the end, once you check all the matrix, then you will find the maximum. You will return as the length of the longest line of consecutive ones in matrix. That is the max that you will return, right, from the function. So let me just show you the implementation that I did. So even if it is a little lengthy implementation, it is very kind of easy to understand. So I just created 8 functions, one for each direction, right. So these are our 8 directions that I listed here, and then I created a max variable. It's just initialize integer mean value, and then this is our function that it's given to us, right. So matrix is given to us, so we'll just check if it is 0 length, then we will just return 0 in that case, longest line. Otherwise we will just create a row and column we will get, and we will iterate through the matrix basically, right. And whenever we see 1, we are going to call these 8 different DFS functions, right, one for each direction. These are our 8 direction, right. This is 1 2 3 4 5 6 7 8. So we have created 8 DFS functions here, and we will pass our I and jth coordinate, and initially the distance is 1. Why 1? Because when you go from this 1 to 1, then it is 2, right, means 1 to 1 it is 2. So initially when you see 1, it is 1 distance basically, right. So that's how and at the end it will just check, if it does not find any max, then it will just return the 0, otherwise it will return max, right. So let us look at one of the DFS functions, because all the other DFS functions are similar. So for example, let's look into this DFS function, right. So if you can look here, I just created the current x and current y is dx and dy we will assign, and we will always assign the distance. We will compare distance with max, right. If it is more than max, then we will just assign distance to the max variable here, and here we are going to get the next coordinate, right, using this direction x and direction y, right, the next one. For example, if you are going horizontally, let's say, right, then you will like go like this basically. So you are in the same row, but you will add one into the column. So that is one of the examples. So you will get next coordinate, right, of xy. Now we will first check and make sure that we are not going outside of the matrix basically, right. So that is what we are checking here, that the dx is not less than 0 it's less than 0, or it is greater than equal to row, or dy is less than 0, or dy is greater than equal to number of columns, means you are going outside of the matrix, right. or we will check that the cell you are on is, if it is less than equal to 0, means we don't want to look into that cell, right? If you are hitting a 0 cell, for example here, we don't want to continue, right? Then we will just simply return. If that is not the case, we will just get the value of matrix into temp variable, and we will update the matrix cell value to -1, right? Because we don't want to visit that again and again, right? So we will just update that value to -1, and we will call our DFS function here by passing our new dx and dy, right? And we will increase our distance that we have traveled is equal to distance plus 1, and row and column are constant, right? And once this DFS function is returned, then we will again assign back the dx dy, the actual original value that it had, right? Temp value. So that is the way the DFS function works. So again it will now call the DFS1, right? Again it will call this function with a new coordinate. So again it will call with new coordinate. So basically, for example, if you are going on to the right side, it will try to go right until it hits 0, basically, right? Like that. So it is going in same direction until it hits 0. If it is hitting 0, then this condition will be satisfied and we will just return simply. So I have DFS 1 2 3 4 5 6 7 8. So it's a little lengthy solution, but it is easy to understand, right? So every time we are going in one direction, right? So for example, in this DFS 8 last function, we are going in the dir 7, means we are going in the last direction, right? And we will be recursively calling the same function, and always we will be keeping track of the maximum we have seen, maximum distance we have seen. So for example, in this case you will see this 1 2 3 4 and 5, so maximum will be 5, right? So that is how the implementation works in Java. So so let us just make sure that our code works here with this example is given to us, right? This one is the given example, and the answer expected is 3 here. So let us just quickly run this. So as you can see, we are getting correct answer here. We can update this solution, this example, with our example, right? 0 1 1 0 1 0. So we'll just remove this and we will update with our example. So this is 1 0, right? 0 1 1 0 1 0, then 0 1 1 0 0 0. So 0 1 1 0 0 0, then we will update 0 0 0 1 0 1, 0 0 0 1 0 1, 0 0 0 1 0 1, and then 0 0 0 1 1 1, 0 0 0 1 1 1, and then the last one is 0 0 0 1 0 1, 0 0 0 1 0 1, right? So this is our example that we tried here. So as you can see, 5 is should be the maximum longest line, right? So let us run this and make sure this works. So as you can see, 5 is the answer, right, that we are getting in the output. So our solution is getting accepted. So this is the way you can use a DFS. So we are using DFS function. In each function goes in one direction, right? There are 8 directions, so we will try to explore all the 8 directions. That's what it does. So we will just go ahead and make this submit. So our solution is accepted by LintCode. So this is the way you can solve one of the Google's interview question, longest line of consecutive one in a matrix, right? So make sure you understood this question and practice this question. And when you are practicing, practice without editor, because in many of the coding tests there is no editor. So you should be able to write the Java code without any help of editor, right? So if you haven't already checked my playlist, then check it out. It has a Leetcode related playlist, over 80 examples solved and explained in Java, as well as Java interview playlist, which has a lot of frequently asked questions and how to answer them. and all like important concepts for Java interviews like BFS, DFS, dynamic programming, as well as Java architecture related videos like hash map, tree map, tree set, hash set, linked list, array list. Those questions are also there. So please check it out. It will definitely help you if you are preparing for Java coding or phone interviews. Also, if you like this interview, please subscribe and like it, because your subscription is very valuable, and your subscription will make the video to reach to more people, and they can also get benefited from this video when they are preparing for their Java interview. So please subscribe, and thanks for watching the video.